Welcome and good morning. This is a quick recording to review naming covalent compounds and to finish it up that we didn't finish last Friday. What you're looking at now are the 3 rules for naming covalent compounds. We want to list the elements in order of increasing group number on the periodic table. So carbon would come before chlorine, since carbon is in group 4 and chlorine is in group 7. Rule 2 is we're going to use prefixes to show how many atoms of each element are present. And rule 3, we're going to add IDE to the end of our last element. In this case, we're doing binary compounds, so second element, just like we did with ionic compounds. Here's a list of our prefixes that we went over last week, 1 through 10. 1 has a little asterisk next to it because we don't start with that. So we wouldn't say carbon monoxide. We would just say carbon monoxide. Di is 2, tri is 3, tetra for 4, penta for 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. These were the examples that we did last Friday. Okay, I'm going to walk through them again as an example. So the first one says carbon, so I'm going to write C. And bromide is from bromine, and tetra is 4. So carbon tetrabromide, remember the subscripts come after the name or after the element it applies to. Dinitrogen, so 2 nitrogens. And tetraoxide, 4 oxygens. Carbon monoxide, so again we wouldn't say carbon monoxide, just carbon monoxide. We don't start with mon prefix. Phosphorus pentachloride, so that would be P for phosphorus, and 5 chlorines. Dinitrogen pentaoxide, so 2 nitrogens again, and penta's 5, so 5 oxygens. And then finally, nitrogen is a diatomic molecule, so we would write N2. I'll review those diatomic molecules here in a second, but we wouldn't say dinitrogen, we would just call it nitrogen. Let's go up and take a look at those diatomic molecules real quick. As a reminder, there are 7 diatomic molecules. They are elements that don't exist alone, they exist in pairs. There are 7 again, and it forms the number 7 on the periodic table like you see here. So nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then hydrogen, our exception over on the left-hand side. So again, those 7 elements are called diatomic molecules. Di for 2, atomic for atoms, so it's 2 atoms together. Since they don't exist by themselves, we could just call them their names. So I don't have to say dihydrogen or dihydride. I could just say hydrogen. And everyone will know that I'm talking about H2 because 1 hydrogen just wouldn't exist. And that holds true for all of them. So going back to the slide we were just working on, instead of saying dinitrogen here or just writing N, I know that nitrogen is one of the diatomic molecules, so I would write N2. This next slide here is some practice. So pause the recording here, see if you can, it's not that one, this one. Pause the recording here and see if you can write the formulas for these names. Right, I'm going to walk through them. You could check your work. Iodine is I, and pentafluoride, so that would be 5 fluorines. Dinitrogen, so 2 nitrogens, and 1 oxygen, monoxide. Carbon and tetrabromide, so 4 bromines. R, diphosphorus, pentaoxide, so 5 oxygens, nitrogen, just N, and triiodide, so 3 I's. Guess I can make that look more like an I. And hydrogen, again, is a diatomic molecule, and so I know to write H2. So that's it for the rules. That's going from names to formulas. Let's see if we can try going from formulas to names. So again, here's some practice for you. Pause the recording here and see if you can name all of these. All right, I'm going to go ahead and flip to the next slide. You can check your answers. We have dinitrogen trisulfide, carbon tetrachloride, oxygen again, because it's a diatomic molecule, we just say oxygen, sulfur dioxide, chlorine is a diatomic molecule, so we could just say chlorine, and diphosphorus pentaoxide. Right, one more practice. I'm going to flip to the next slide. Here's a look at covalent compounds and ionic compound naming side by side. So pause the recording, try these two. Right, I'm going to go ahead and highlight the name. So on the left-hand side, we have NO3. Those are 2 nonmetals together. So this is a covalent compound. There's no charge, so it's not a polyatomic ion, although it looks similar to 1 or 2 of them. Just a covalent compound, and so I would call it nitrogen trioxide. So that is this one right here. On the right-hand side, this is magnesium and nitrogen, so metal and non-metal, so ionic compound. Therefore, we don't have to name the little subscripts because there's only one way to put this puzzle together. It's very specific, so I could just say magnesium nitride. I don't have to identify any of those numbers. And so moving forward now, we have 2 sets of compounds and different sets of rules for both of them. And so what you have to do is look, identify the type of compound you have, and then write the rules. Or use the rules to name it. And that is it. So the last slide I have for you here is just some common names. So again, these are some covalent compounds that we wouldn't name with the prefixes because they have common names that we use. So ammonia, NH3, we would just say ammonia instead of calling it nitrogen trihydride. We have methane, CH4, which is the first of a whole bunch of organic compounds that have their own naming rules to them. But we'll see methane quite a bit. So methane again, CH4 instead of carbon tetrahydride. Methane actually is the technical name for that compound because it's an organic compound. Water we'll just call water instead of dihydrogen monoxide. And then finally I added a 4th one, ozone. There is no kind of common name / technical name for it. Ozone is just ozone, and that would be O3. And that's it. And so to leave you then, the assignment is to try Homework 407 Part 2. If you haven't yet, it's practice naming. Make sure the ionic compound lab is complete and turned in if you haven't done that yet. And I will see you tomorrow. We'll start on those structures. Have a great day.